Thank you very much. Good afternoon. So we will start the demo session of this afternoon with Dronus. I ask Marco Buscemi to come here to the stage. So the demo we are going to discuss is controls with distributed systems.
Just a second.
Yes? Okay. Okay.
Sorry.
So I think we'll start in just a minute. Some technical difficulties.
Perfect.
Okay, so Marco, welcome to the stage. So let's start with introducing Dronus and the demo you are going to show us today. Yeah, it's working.
Okay. Okay. I hope that Ricardo, we can hear us. That is the person that will follow us during this demo.
Okay.
It's one part of our software team that follow us in this.
So firstly,
experience.
I would like to ask you to present briefly the solution you are developing. That is something like a drone in a box. I don't know, maybe you can define that a little bit more.
Mm-hmm.
Please go on.
Okay. Our solution is composed by this drone in box that is composed to the nest. That is the docking station. And the drone. Our docking station is the point of communication to our ground control station that we will see in this demo. It's called Dronus Planner. And the drone, and which one? And that help our system to communicate with the drone and download in real time and in a second time after the mission the download of data.
So it's something like, I don't know, maybe we have no picture right now, but just to describe physically, it's something like city light, so city light pole that has like a drone in it, and then when you have to start a mission, the drone goes out and go to do the flight, right?
Exactly. The design was studied to be in the minimum part visible for Vandali Star Act.
Okay.
And this is the way that you say like a light, city light, because it would be a design that can be used in a building or in which place in the city you want.
Okay, so let's try to talk about the use cases and something maybe you already experimented in real life, some examples of use of this kind of solution.
Okay. We use this kind of solution for monitoring or city monitoring. How I said this morning, it can be used.
Okay.
It can be used for monitoring outside and inside too, because we have a system that is based in ultra-wide band solution that permit us to operate in outdoor, but in indoor too. How we can see, this is our test area in our building, in our company, and it's a demo indoor. And now we will see the demo in this room that it's not much. I don't know how do you say, but it's a little. It's
pretty small.
Yes, exactly. Okay. It's little.
Do you think we can start with the demo so we can show the mission, and then it will be maybe more clear?
I should add Riccardo. Give me just any second. I don't know why it doesn't connect. Riccardo, you can hear?
So let's see if they can start the demo.
Yeah. Okay. And Riccardo, I don't know.
Can you use the chat maybe?
Yeah, exactly. And it can be used for monitoring, but just for surveillance, safety, and for prevision of environment disaster, for example. But we have other kind of drones. For example, the K15. The K500 that we can use for other kind of use. Okay. For example, warehouse, or in base of technology that we customize our drones. In base of technology that we use, the drones can be used for different usage.
Okay, so let's try to solve the problem. In the meantime, maybe we can go on with the discussion in the meantime.
Give me just a second, so sorry.
Il bello della diretta.
Exactly. Just sorry, I was bored. Riccardo is here, but
if you want, we can do this. Maybe we go on with the next demo, and so thereafter, when you solve the issue, we can we go back with the.
Maybe it's
demo.
better.
Okay.
So sorry for this.
Don't worry. So I asked to come to the stage to Antonello Cedrone and to Danilo Leanza and to Gennaro Paduanelli from Exprivia. So now we will present demo remote surveillance with systematic and targeted collaborative actions. This was a demo that DTA with collaboration of Telespazio and Exprivia realized last week, I suppose. So we made a mission inside the port of Bari. And so I asked Antonello to give us an introduction on that, and then we can show the video clip.
Okay, thank you. Good afternoon all. So I'm going to introduce to you what we realized last week with DTA colleagues. So let's start with use case. So the use case is about the law enforcement and security use case. But it's also a use case that makes drone cooperating each other. This means that we considered two different drones, one Mavlin custom drone, and another one, it was a DJI commercial drone. The first drone was equipped with a thermal camera and optical camera in order to detect people inside an unauthorized people site, an example. The goal of this mission is to detect some dangerous behavior, and the video streaming that was acquired by this video was redirected to a platform. Our platform, it is called T-Drones, in order to georeference this problem and to provide this information to a second drone that could be equipped with a more performant camera. For this case, we used the Mavic 2 DJI drone that can perform on another flight. So which were the technology that we set up for this use case? So, of course, the drones that I explained, so two different drones, but also the decom box, that was the com box that is installed in a Mavlink drone. It is done by Telespazio. It provides you different services as the resilient connectivity, but with the Iridium satellite connection and LTA. And also the digital platform. It's very important because you can manage different flights at the same time without any needs of two different pilots.
Okay, so maybe we can go with the video clip, so we can show the mission, and then we describe what happened. So we can see here a drone from DTA that was used to perform the mission. Maybe Danilo can tell us a little bit about the perspective of the drone operator using this kind of technologies.
Yes, thanks. So as DTA, we provided our drones and we got on board the box developed by Telespazio, and we routed the telemetry to Telespazio for a full control of the drone by remote through the T-Drones platform that is a fleet management platform, correct?
Right.
So apart from the technological aspect, what we are focusing on the solution that will enable a lot of use cases for the municipality, for the ports. So it's very important the focus on solution and obviously on the platform. Antonello is going to explain probably.
Yes.
Yes, please go on.
Yes, basically what you say, Danilo, is what we see now on video. No? So for our perspective, it's very important to define what to do. So by the means of this platform, it's a platform that is web-based. So basically, we can control by this technology all the drones via internet and satellite connection for the last miles, let's say. And it's important to define the target. So you see the boundaries of the mission. This is what we call mission. So the boundary of our job, but also time constraint, when you have to do something. At a certain point, of course, you have to do flight planning. Of course, people use or DJI codes or mission planner if they use Mavlin drones or other tools. We provide a default planning tools, as in this case for manual planning, or we can see in the next figure, grid planning for automatic planning, design the boundaries of a mission, and providing you an automatic flight plan that you can change. An example, modifying parameter as the GST that can influence the 8. Of course, if you don't want to use it, this basic planning feature, you can import additional flight plan that at the moment we import Litchi flight plan or mission planner flight plan for the two most important categories of drones, DJI and Mavlin. Yes, in this case, we see how we can change GSD, and the 8, of course, change as well. Another important things that we have realized in the last months in T-Drones is the possibility to set an automatic action just in case the drone goes outside the buffer. In example, we provide basic feature as the return to home or the land feature. This means that we want to evolve in the future in a vision that allows to the drone to perform something in an autonomous way. So this is the flight plan that we used for patrolling for the first drone mission. And now we switch on in the second phase, using.
Yeah, now we were talking about the technology that was enabling this kind of mission. I wanted to go back to the mission itself and then to describe the kind of service that we simulated, that we experimented here. And the first question is to Gennaro, because during this mission that was basically the systematic control of the portual area, also Exprivia had a role of having the let's say putting a platform to make possible this and also to connect the control of the drone flight with other elements inside the port area. So maybe you can describe this.
Exprivia developed an IoT platform for monitoring smart cities, and in this case, as we can see, we have the plan that T-drones made with their tool, visualized on the map, and during all the flight on the portual area, we monitored how the drone was going, how the mission was going, and we then visualized all the data that even a sensor, a nose sensor made by Befreest, was acquiring data of the pollutant present in the air. So that we could then persist this data on our databases in order to then make some statistics and data visualization on the map.
Actually, since we are talking about also Befreest, I would like to ask Fabio Cerino to join us to the panel since we are here, so this video is starting. Just another question to Antonello regarding the previous video. So we talked about T-drones, but there was on the drone also a box installed on it that was made by Telespazio. Maybe you could give us more details on that.
Yes, this box is very important because allows you to have, as I said before, a resilient communication. No? So, okay, you have LTE. Basically, we use a lot of LTE connectivity because we have it in many places, but there are places where you don't have this kind of connectivity. Thanks to this box, you can switch automatically on a satellite connection, and you can retrieve the things which is most important at all, which is telemetry. So in your platform, you get in any time this information, but you can also add additional values. As an example, the integrity functions by the means of navigation gateway, so we can connect to the EGNOS network, and to retrieve also the more accuracy on the position of the drone. So the box is one solution that that allows T-drones to communicate with drones remotely.
Okay, Danilo, we are seeing right now the second mission that was realized inside the port of Bari. Maybe you can describe it and highlight also the fact that the first one was a possible systematic inspection of the port area, but the other one had a different use case regarding environmental protection. And then we go with Fabio to describe that.
Yeah, sure. The first kind of experimentation it's very important because focusing on the solution, we are able to satisfy a lot of requirements coming from the end user, such as the municipality, the port authorities. Since, from my point of view, we need to focus on the solution because are the solution that drive the industry. So, Having this
Can we go with the second video from the production, please, again, so we can see that and comment the picture?
Yeah. So apart from the payload that can, in this case, is a box, and in the other case is just a sensor, we are able to perform a lot of use cases just for systematic action, for systematic scenarios, having the control by remote, from T-drones or something else, but mainly by T-drones. So we just need to capture the requirements from the end user and try to implement the necessities. So in the second case, we just started with the Befreest, a first experimentation, getting on board a sensor for the pollution detection, let me say. Here, differently from T-drones that we pass the telemetry and so on, we just got on board this box. It's a standalone payload, so we just printed in 3D the support, but this is another word. So, and the most important thing is that we probably is one of the first kind of use cases of this for that. So we started, and we need to work on that just to capture the best solution for pollution detection. But this is it's a matter of
Please, Fabio.
of Befreest. So Fabio,
Yes,
please.
Yeah, thank you. Good afternoon, all. It's a very pleasure to stay here because really it's the first time that we made a first air pollution monitoring with a drone. For us, Befreest is a company that is involved in a air quality management system in indoor places, but in the Calliope project, in the House of the Emerging Technologies of the Municipality of Taranto, we are exploring a new way to capture information regarding air pollution in cities, because we think that our cities could become not only smart but health cities. Is a new paradigm to live better in the place where we live the most time of our life. And for this experiment, we try to capture for the first time some pollutants in the air, just like PM particulate matter 10, particulate matter 2.5, and particulate matter 1, and to verify in different altitude the concentration of these pollutants using drones. And yes, it's the first step. The journey is very, very long because we have to verify the quality of this information that we captured with the drone, but we are confident, very confident, that this is a new way to improve the way to monitoring our cities in a better way. It's important this because air quality monitoring is made in this moment by a really low number of detectors in the cities. And we know which is the air quality in one point of, I think, for 20 square kilometers. But we don't know really what happens outdoor this building. Our mission is to create a new way to get information really near us, near the people, to give information regarding not only the air quality, but also regarding the risks that they are passing breathing some pollutants. In Calliope project, we have a particular application of our technologies that correlate information that we will capture with a wearable device, monitoring also the physiological parameters of 50 policemen that will be, yes, where with a lot of sensor that could give us the correlation, the short-term correlation between air pollution and the short-term effect on the health.
So, like, the question now is what the using a drone for environmental monitoring allows us to do with respect to, for example, ground monitoring or something different.
Yeah. Yes, normally we base all the elaboration with information that are at the ground level, 2 or 3 meters of altitude, not more. The idea to use the drone is to verify the effect in urban environment, regarding how the concentration could increase or not decrease regarding the altitude. In the city there are the canyon effect, and the canyon effect is very important in an urban environment, because at the 10th floor we could have an air quality different regarding the ground level. So if you plan a mission with a drone at different ground level, you could have a 3D digital twin of the urban spaces of the air quality that we breathe every day. So this is very, very important to explore also the effect that the air quality have to people, and the exposition that people has, and the risk that they pass when they are exposed to that air pollution.
Yeah. And this sensor, as well as the data gathered from the drone of the Telespazio mission, were also put inside the Exprivia platform. So in this case, it's very, I think, interesting and useful to understand how, for example, during time, the environmental data gathered can be processed and utilized.
Yes, with our platform, we were able to collect data and then visualize graphically how during time the values were changing. And we had also set up a pipeline where when some of the pollutants were going over some levels that national authorities set up for us, we then created at real time at the exact position in which that measurement was made, a placeholder in which we told how and what pollutant was over the normalized level. Then, at the end of the mission, we can then batch elaborate the data in order to visualize them on the map, making what is an heat map, even a 3D heat map, if we get data from several levels of altitude, so that we can then visualize how the air is polluted or not in a more correct way.
So basically environmental protection and also the systematic surveillance. So many use cases, connected with the theme of the smart city. So thank you very much to all the people here on the stage. Thank you. I think we can go now back to Dronus demo if it works. Thank you, gentlemen.
Thank you.
Okay, now we are.
So we have a second try with this. Let's see if it works. So can you see the screen? Okay.
Okay.
Please go on with the demo.
Okay.
Please go on with the demo.
Okay. Here we are. Our Dronus planner. That is the I was saying the ground control station. How we can manage the mission, the waypoint, and how permit us to load the data of drones and data of environment that drone can detect.
So right now we are watching at the flight planner from the your system that is carrying on with the mission.
Exactly. Now, Ricardo, we can start the demo, the fly. Ricardo, if you heard us start, now it will start the releasing. And Ricardo, I don't know why. And Ricardo confirmed the releasing, and how you can see the mission will start, and the drone is releasing from the docking.
Let's see.
Now the drone start his mission. I don't know.
No, I think it's mine. Let's try this. Maybe it was the microphone on the smartphone. Yeah, I think so.
Okay. Then the drone start his mission and go around. In this case, it's indoor.
Okay, we can see that.
Yeah, exactly. This is the drone inside our areas that started his monitoring, and in our Dronus planner you can see now the connection is not good because I'm in hotspot, but now you can see in real time the detection and of the camera in real time, but you can also download in a second time after the mission. When the mission is closing, is done, you can download the video and see the video in a second time.
So basically, if I try to understand, the form factor, of course, is one of the most interesting parts, because you have like something like a city pole light that releases a drone, and then you can use that for different use cases. So what is the service model, the idea of some types of use cases that could be interesting for this kind of solutions?
We have different kind of solution that I was saying you can use for monitoring or for example, prevention of disaster, but we use it as co-working of drones, because for example in near Naples we had the furniture of 9 system that co-working at that can work together, and the client can download the data of the system and can see in real time the parameter of the system and the drones too.
Okay, so I suppose that your future vision is something like having a large number of this kind of platform distributed all around a city, for example, to do monitoring services, to do other kind of stuff, maybe gathering data and some kind of things. Maybe you can give us your thoughts, the thoughts of Dronus, of the new future vision of this kind of solution.
Exactly. If you think about smart cities, you should think in co-working of drones and solutions that can work together. Drones, but other kind of solution. just how I said this morning, for example, this kind of drones, we obtained inoffensiveness report DVR that certificate that our drones can be fly over populated area with the minimum level of offensivity. This permits us to co-live with people and with cities.
Okay. So Marco, thank you very much. We managed to demonstrate, I think, everything. I don't know if there is something else that you want to show us.
No,
in
it's okay.
Other guys. Okay, so let's go with the next demonstration made by Sirti. So I call to the stage Riccardo Invernici and Danilo Dello Buono.
Hello, Mario.
Hello, Riccardo. Hello, Danilo.
Good afternoon.
So I think in the meantime I ask the production to go with the slides, and then this is the remote control. So first of all, maybe you can describe us a little bit about Sirti, a little bit about H, and also tell us what a telco infrastructure enterprise and the software enterprise are using drones in their processes.
Okay. Good afternoon. Can you hear me? Yes? Okay. Good afternoon to everyone. My name is Riccardo. My company is Sirti. And together with my colleague Danilo and his company H, we are here to explain it briefly our operational experience about using drones to support the development of smart cities. And here. Some words about my company. More than 100 years of experience as a protagonist in telecommunication here in Italy. We deliver and we make maintenance field and mobile networks. I underline for this specific context the mobile networks. We have commitment with all the mobile operator here in Italy. It means TIM, Telecom Italia Mobile, Vodafone, Wind3, Iliad, and the tower operator, Inwit and Cellnex. We still remain the point of reference in building networks, telecommunication networks, because, for example, in the related project on next generation EU PNRR here in Italy, we are the most relevant supplier of both fixed fiber optics and mobile, new tower, new antennas, new BTS, acronym from Base Transceiver Station in Italia, SRB, Stazioni Radio Base. We have two of them on the rooftop of this building. When you go out, you can see the tower, the telecommunication tower. So you can see my colleague in the picture. In this context, our job is very dangerous. We have often to go, we climb up to the tower at the antennas 8 often, okay? Now some word about H from Danilo.
Yeah, you can use this.
Okay. Good afternoon, everybody. My name is Danilo Dello Buono. I am an architect and I work for H Software. Just on this one, please. Okay. What you see are some images of our headquarters, zero building energy located in the European mountains. AK Software is the Italian market leader for AEC software and has produced more than 100 software since 1989. Over time has achieved various records, including the one to having been produced the first common data environment certified by Building Smart International. Nowadays, AK Software is also the company with the largest amount of open bin certified solution in the whole world. Thank you. I leave the floor to Riccardo for...
Yeah, I think we can go with, understanding how Sirti is using drone in their processes, maybe.
Okay. 5 words about the 5th generation mobile network, the 5G network, mobile network. This is the real enabling technology for smart cities. 5G, in addition of 4G, is not only high speed. We have 2 news. We have a very low network latency time, is the time of answer of the network. And this is so relevant for real-time services of smart cities, such an example for car, driverless car, aerial system, unmanned UAS systems. You can see the importance of latency time for the safety of the system. If the network don't answer, is dangerous. And the second news, in addition of 4G network, is the ability to manage millions and millions of devices for IoT, for Internet of Things, domotics, industry, and so on. So for us, for the builder of network, for the network builder, it means a lot of antenna, more and more antennas to project, to measure, to design, to install, to maintain, to manage. And in so many time, we have to go to climb up the tower with humans. My colleagues, a lot of time for each antenna must go up to the tower. So, why the drones? Easy. We cannot install antennas for now with drones, but we can carry out some other important tasks before the installation and after the installation for maintenance, for example. Here in my slide, some example. For example, before the installation for the permits, we have to create and supply a digital representation of the neighborhood, 300 meters around the new antenna for the permits, and we have to simulate the electromagnetic field exposure, only power. And for example, after the installation, we have to check continuously the correct antenna's direction. It means tilt and azimuth. And because of we have to continuously change the configuration on the top of the tower, we must have the control, exact control of the asset management on the top of the tower. So, what we are trying to do. In the case of an existing tower, we are trying to build a tridimensional model, build a tridimensional BIM model. The acronym means Building Information Modeling, as my colleague Danilo will explain to you after. And we hope we help to build the 5G network. It's up to you.
Thank you. Okay, I'll try to describe what the possible workflow we designed together with Sirti for the building of this information model. We investigate various technologies for the surveying. The final result, in any case, is made up of a point cloud. This point cloud may be produced with area photogrammetry or with LiDAR devices, both from the ground or installed on drones. To achieve the highest level of resolution and precision, the LiDAR technology was the clear choice for surveying the towers. Furthermore, the use of drones enable to have a comprehensive survey of areas that are otherwise inaccessible. I'm thinking about all the upper part of the tower structure, or scenarios where the tower itself is enclosed or fully or partially into inaccessible terrain, such as slopes or fenced areas, for instance. On the other hand, the use of drone must be preceded by an authorization process in the case of reserved airspace. And this authorization, for some reason, in some kind of areas can also be denied, of course. Let's see some images of the survey campaign, starting from the positioning of a registration mark for process the point cloud afterwards. Also, the area photogrammetry drones have been investigated for the surveying of the towers. For the survey of the surrounding areas, we emphasize the use of aerial photogrammetry, like you can see in these pictures. These techniques excels in providing the required level of details to to model a 3D building while preserving the spatial relationship with the BTS tower. Here we can see the drone landing. After being produced, this point cloud can be either processed to obtain data useful for modelation, or either used directly as a support in modeling operation. The processing of the clouds include segmentation to extract single elements, noise removal to clean the point cloud, and fitting of oriented planes in order to check the pointing direction of the antenna, what Ricardo has mentioned before, and so on, much more. And on the other hand, the modeling with direct support of the point cloud includes the importing in beam authoring software of the whole point cloud, and then the extraction of portion of this point cloud at a higher resolution. This high-resolution portion of the clouds opens up the possibility to model directly within the point cloud with the snap-to-point cloud functions. Lastly, information modeling process have been conducted to obtain what is called a beam model. We can briefly see some phases of this process on a parabolic antenna installed on a tower. We can reconstruct the mesh starting from the point cloud and then extract discrete profiles. Also, very precise measurement can be taken directly from the point cloud. For the modeling of this kind of profiles and deliverables that have then been imported in parametric modeling software to obtain the definitive geometries. For the modeling of the surroundings, as I said, we have the possibility to import a whole point cloud. This is the natural way to obtain a correct spatial reference between the 3D model buildings and the BTS tower. This is a very critical aspect for the electromagnetic fields design purpose. According to the project scopes, afterwards all the beam models and the point clouds were uploaded to collaborative cloud platforms. This enables the possibility to use multiple functions offered by bidimensional, three-dimensional formats using just a simple internet browser. This platform is compliant with beam national and international regulation and offers very useful tools for co-working, like issue management, user access control, data audit trail and logging, and much more. Within this environment, further enhancement can be made to the beam models, establishing links to various types of documentation directly to the model, giving us the opportunity to obtain a specific insight within every single element included in the model. In this environment, you can also design static maps in which the link to the beam model or the point clouds can be placed, so you can directly navigate to the beam model, and selecting each single element, you can access all the information stored in it. And also I have access to specific documentation, or you can federate various models. Federation simply means the ability to view a different model with different characteristics in a single view, like a three-dimensional representation of the electromagnetic fields together with a physical model. This approach opens up a completely innovative way of navigating the model, like linking the picture of the device to the device itself within the model, or access a specific page of technical documentation during maintenance operations, like the connection under an antenna. Within this environment, it's also possible to navigate 360 pictures, and these images are perfectly coincident with point clouds and beam models. So you can, for instance, take direct measurement on this interface. Starting from these methods that includes the surveying technologies, the production of point clouds, and the beam methodology, the possible development for the future are countless. We can enhance the utility of this system, for instance, by leveraging API connectors to integrate data models with the company's facility management database. Or another practical idea could be the labeling of all the devices installed with QR code or RFID in order to enable the operators on the towers to access directly with a mobile device to all the specific documentation stored in it. Another possible scenario could be the positioning of all the deliverable in a GIS environment. So to be able to access all the archive with a single access point, and at the same time being able to consult territorial and geographic database, maybe making available online. Let's see a rapid demonstration, just zooming out on a facility placed on our 3D representation of the Earth. We can access the point cloud. Maybe we can activate the schematic representation of buildings or change the base map on which this model are inserted. We can also in this environment inquire for information on a single element, or at a larger scale we are able to access information stored on geodatabase, making available from a regional environmental agency, for instance. With this I finished, and I leave the floor to Riccardo for some
few words
final
for the future.
Conclusion. Thanks.
Building the future. We trust in the future, we build the future, and so we can imagine other use of drones in our works. For example, electromagnetic fields measurement, more complicated, not only power, interference hunting, radio coverage management among the radio base station, remote training with virtual and augmented reality, and in the future, automatic visual inspection with a drone in every place in which we have a base station. And we need the technology. We need room to evolve. We are waiting for them to evolve. A critical issue by the moment for us is, for example, the battery life, the weight of the battery, the costs, especially the LiDAR on a drone, to have expensive in this moment, but the main critical issue for us in our context of smart city is red areas. You can see in my example, this is Rome, and we can't fly in the red areas. We can't build the 5G network with drones in the red areas, and we need some specific dedicated category to fly in the red areas. For example, to be able to fly around 5 meters on the existing tower. Well, we are done, we are finished. So we hope we haven't bored too much. Thank you for attention.
So, okay, just a very quick question before finishing with this moment. I just wanted to ask you, how is Sirti, from an enterprise point of view, implementing the use of drones? No, because in the previous demonstration we saw providers of solution, drone operators, but you are, let's say, on a user side perspective. So it would be, just interesting to understand that in just 30 seconds, if you can give us an overview on how you implemented the use of drones inside your processes for example, the life cycle of infrastructure antennas.
This project is a startup project inside my company. I have 12 colleagues that have open A2 category. They are pilot. We are trying to build this model able to manage the tower. This morning I talked with ENAV, a representative ENAV, and he explained me that we can create a self-assessment to propose to ENAV a dedicated specific category to fly in the red areas, for example, and maybe we can start to think about this, to propose to ENAC a model for our purpose.
Okay, thank you very much. So this concludes the first session. Thank you very much.
Thank you.